Hello, it's a pleasure to talk to you today. I'm going to be discussing how we can create a resilient, sustainable future and what role computer science and technology can play in helping to deliver that. As we look as a society to how we can emerge from the coronavirus pandemic, we must face head-on the threats posed by growing social inequality, by the destruction of nature, and by climate change. Now, just to give you a few statistics around each of those, if we look at social inequality, in the UK, social inequality is severe. Globally, it's extreme. The richest 1% of the world's population has more than twice as much wealth as 6.9 billion people. In terms of our natural world, it is estimated today that 1 million species face extinction in the coming decades. And in terms of climate change, there are unfortunately many dire statistics that I could give you, but here is just one. Today's atmosphere, in terms of the levels of carbon dioxide, is unprecedented throughout all of human history, prehistory, and beyond. In other words, the air that we're breathing in today has more carbon dioxide in it than the air that's been breathed in by any of our forebears. Now, I'm going to talk primarily today about that last threat, the threat of climate change. And so I thought I'd just show you the actual data behind the statement that I just made about the unprecedented nature of today's atmosphere. And here is the data. It comes from Antarctic ice cores. And what you can see in this image here is a photograph of a slice through an ice core. And if you look really carefully, you should be able to see tiny bubbles of air. Those are ancient air that's been trapped in the Antarctic ice and is recovered when we drill down through the ice to drill for these ice cores. And the data that you see here is the levels of carbon dioxide in those bubbles of air going back over the last 800,000 years. And what you can see is that it's varied, the levels have varied up and down, but within set bounds, within about 180 and 280 parts per million over this very long period of nearly a million years. And this variation up and down has occurred as the world has moved in and out of ice ages. The world's moved in and out of ice ages as the orbit of the Earth around the Sun has very slowly varied over these very long time periods. And to give you just a sense at a local level of quite how different the climate has been over these different periods, if we go to the last warmer period of Earth's history, around about 120,000 years ago. If you go to the Sidgwick Museum in Cambridge, then in amongst all the dinosaur bones, you can also find a fossil record of giant elephants and hippopotamuses that used to roam the region in that warmer period. 120,000 years ago, that were then replaced by woolly mammoths as the world moved into an ice age in the more recent past and then back into a warmer period. But we can also look at where today's levels of carbon dioxide are compared to this historic record, and that's where they are, over 410 parts per million, vastly exceeding anything that we've seen over the last 800,000 years and indeed much further into the past as well. Now, the implications of that on our climate are very profound through the greenhouse effect and the effect that that has on our climate. And here are just some examples of the impact of that. So we've seen around about 1 degree of warming to date, 1 degree Celsius of warming to date globally, but that is associated with very significant increase in the risk of extreme temperatures. We've seen extreme heat waves around the world, and we've also seen wildfires occurring in different locations around the world, in Australia and California, for example. As the world's warmed up, we've also increasingly seen the melting of ice around the world, and that's particularly impactful in terms of the melting of the vast ice sheets covering Greenland and Antarctica. And we're seeing an accelerating rate of loss of ice from those vast ice sheets. That loss of ice, combined with a warming of the oceans, which leads to an expansion of the water in the oceans, is also leading to an accelerated rate of sea level rise. And a final implication of rising carbon dioxide levels in the atmosphere is that we're seeing some of those increased levels of carbon dioxide finding their way into the oceans, and that makes the oceans more acidic. And levels of ocean acidification are soaring, with impacts on marine life, in particular, for example, coral reefs. Now, the greatest impact to society from climate change is probably through the impacts on extreme weather. I've already mentioned the increased risk of heat waves and of wildfires that we're seeing around the world. This map here, all the dots that you see are examples of extreme weather that have occurred around the world in recent years, and all those dots that are coloured red are examples where we've been able to scientifically look at those extreme weather events and ask the question, has climate change increased the risk of them occurring? And all those red dots are where it's been able to be shown that indeed climate change that's already occurred to date has increased the risk of those severe weather events, and in many cases increased it very substantially. So the sorts of extreme weather that are represented by those dots, we had a very severe heat wave in the UK last summer in 2019, and indeed in Cambridge was recorded the hottest temperature ever on record in the UK, 38.7 degrees Celsius, recorded in the Botanic Gardens in Cambridge. But the other real impact that we've seen in terms of extreme weather in the UK in recent years is repeated episodes of severe flooding. And you can ask the question, how is that connected with rising temperatures? But it's a simple implication of the physics that as you have a warmer atmosphere, it's able to hold more water vapour. So a warmer atmosphere is essentially a wetter atmosphere, and that increases the risk of having heavy rainfall events, and therefore increases the risk of flooding. Now, what I want to talk about for the rest of this presentation is how computer science and technology can be used in response to this. And I want to talk in particular about two ways in which computer science and technology can be used in response. First of all, I'm going to discuss how it can be used to help us to assess and to monitor the risks. And then I'm going to talk about how computer science and technology can be used to help to contribute to sustainable solutions. So let's look first at assessing and monitoring the risks. It's the case today that we have an understanding from observations of our changing environment that is absolutely unprecedented. We really have vast data sets now that are coming from a very wide variety of sources, telling us about every aspect of our natural world. Some of that data comes from satellites, from space. Some of it comes from the ground, from networks of sensors. Some of it comes from computer simulations of ever increasing complexity of the natural world. And some of it comes from all sorts of different sources, crowdsourced data telling us about instances of illegal deforestation around the world, for example. Now, I said that there really are vast data sets. Each one of these diverse data sets are ever growing in size. In terms of the information that we have from space, it's estimated there's something like 10 terabytes of data coming in, and that's increasing every day, and that's increasing all the time in terms of the size of that data set. Some of that data is coming from satellites launched by the big space agencies, such as the European Space Agency, but increasingly it's coming from private sector organisations that are putting fleets of low-cost satellites into space, and then assessing many different aspects of our environment through those data sets. We also have increasingly diverse different data sets on the ground, and here's just one example of the sort of diverse data that we have. This is this plot here shows some 4,000 floats that are continually observing the ocean from the surface down at depth. They trace up and down and measure different properties of the ocean, and then report their data via satellites actually back to a central database. And so we have a continuous observation of the ocean properties throughout the world's oceans that give us an unprecedented level of understanding of how our oceans are changing. But there are many other different networks of sensors telling us about different composition of our atmosphere, the different aspects of all the different habitats around the world, different species, and how they are changing, and these are all being monitored in very different ways. And one of the key challenges then is, how do we make sense of these vast data sets? Make sense of them to understand both how critical aspects of our world are changing, and also whether or not things that we have put in place to try and protect those different aspects of our natural world are actually having any effect. So one of the, I thought I'd give you an example of something that we're involved in Cambridge, where we are trying to use aspects of computer science and technology to help us to make sense of those vast data sets. And this is one example that we've been working on over the last year or so. One of the key questions for many businesses now, who are increasingly recognising that climate change is a real and present threat to their businesses, and that they need to both understand those threats in terms of the risks to their business operations, but also the impact that their business is having in terms of increasing the threats posed by climate change. But one of the key things that businesses need to understand is how climate change may affect their operations at a local scale. And in fact, that understanding of climate-related risks at a local scale is important for all sorts of different aspects of decision making, but it's quite difficult scientifically to determine. We can run large, complex computer simulations of future climate, but we're limited by the resolution at which we can run those simulations. And so to provide details, particularly of extreme weather, which is the thing that has the most impact in terms of businesses or society, to predictions of extreme weather at an individual location is very challenging. And so what we've been looking at is whether we can combine the computer simulations of future climate that we have together with historic observations of weather, particularly extreme weather, at particular locations, such that we can come up with improved predictions of the risk of extreme weather impacting, for example, business operations in particular locations. And we've been using machine learning tools and techniques in order to synthesize those different sources of information. And that's what you see an example of the output of that methodology presented here, in terms of us starting to develop a climate change business risk index at a local level. But there are many other different aspects where we can start to look to see how we can use different data science tools, particularly machine learning, to try to better quantify the risks in different aspects of our natural environment. So, for example, we might be looking at how we can use information from space to give us more information on changing habitats and look to see whether we can use machine learning algorithms to go from the raw data that we have coming in from satellites to give us that information in terms of different aspects of habitats and how those are changing, or using visual imagery from space to actually be able to count different numbers of species in populations. So we've been using that to look at the evolution over time of a species of whale from satellite data, counting individual species, or similarly populations of penguins, for example. So ever increasing information that we have that needs to be analysed, and looking at new computer science tools that can be used to help us to actually extract the key information from the data sets that we have. Another example would be using machine learning techniques to be able to synthesize different data sets. So in terms of carbon dioxide emissions, for example, we have many different sources of information on what carbon dioxide emissions might be, combining together those different data sets, many of which have different uncertainties or different levels of confidence in those data sets. They might be have very different spatial coverage. So looking to ways to combine together the different information that we have using machine learning tools is another really important application of those machine learning tools. Yet another example might be looking at heat loss from buildings. So in terms of the response to climate change, we know that we need to make our buildings more efficient in terms of their use of heat, and so can we look at different ways of monitoring that and using again computer data science techniques in order to be able to do that. So that's just a few of the examples in terms of assessing and monitoring the current level of risk. If we then turn to how we might be able to use computer science and technology to help to contribute to sustainable solutions, I wanted just first to pause and look at the scale of the scale and the pace of the change that's required to respond in particular to the climate related threat. And so what is shown here, the white dots that you see on this graph are over the recent past global levels of carbon dioxide emissions, together with a prediction of what they might be in 2020. So because the world has been in lockdown for much of 2020, it's anticipated that emissions might be slightly lower globally than they have been in the recent couple of years. But the levels of decrease that are required if we are to limit climate change, in particular limit climate change to 1.5 degrees of warming with some reasonable chance, are really dramatic, and that's what's shown by the blue curves in this graph. So in the UK, we currently have a commitment to reduce our emissions to net zero by 2050, which is broadly consistent with what is shown in this graph. Really, globally, the emissions need to be reduced down to net zero by around about the middle of the century if we are to have a good chance of limiting climate change to just 1.5 degrees of warming. But that's a really significant change that's required in terms of a transformation of global economy to net zero over just a couple of decades. And so there really is a big challenge in terms of how anybody in society, but particularly the computer science and technology industry in this instance, could help to contribute to delivering that very, very challenging task. So let's look in a little bit more detail about what exactly that means in terms of our economy. So on the left-hand side of this slide here is an image that was put together by the UK Committee on Climate Change a couple of years ago now, showing how emissions in the UK have changed in different sectors over recent years. And there has been quite a decrease overall in emissions in the UK, but that reduction has come primarily from the power sector. And that's in part because we now use very little coal in our generation of electricity. And it's also come about as a result of increased efficiencies. But what you can see in this image, that if you look through other sectors, if you look at transport, if you look at industry, if you look at our buildings, there's been rather little change, a little bit of a decrease in the energy use in buildings and the emissions as a consequence. Not very much of a change in the transport sector, not very much of a change in industry. Other sources of emissions from agriculture and land use and from waste, for example, are also pretty flat over this time period. And as I said a moment ago, the challenge is that all of these need to reach net zero over the next couple of decades. So how can we go about achieving that? On the right hand side, I thought this was an interesting image. It came from a report that was put together by the UN at the end of last year. And it just looks at the, among other things, the embodied energy in a smartphone versus all the different technologies that smartphone replaced. And it's just one example of how actually technology can play a really important role in terms of the solutions around climate change in particular. Now in Cambridge, I'm actually the director of a new initiative in the university called Cambridge Zero. And a key element of what Cambridge Zero is doing is looking across the research of the university and seeing how the research across the university can contribute to solutions to climate change. And we have 6 thematic areas that we have brought together under the research pillar of Cambridge Zero. And I thought that I would just run through each of them, because in each of them computer science and technology can play a really critical role. So the first thematic area that we have is around zero carbon energy transition. And it's very clear, I mean, it's already the case that computer science and technology are playing a significant role in terms of delivering that energy transformation, whether that's through smart meters or whether that, meaning that we use our energy more efficiently, or in terms of being key components of some of the technologies that are helping to deliver zero carbon energy. The next area that we have is around health and society, and a key element of that is around behavioural change. How can we help everyone in society to live lower carbon lifestyles? One thing that we did in Cambridge last year around this was to run a competition amongst our students and staff to develop some kind of app or other game that could help people to see how they could decarbonise some aspect of their lives. And it's clear that that technology could be a really critical component of helping to deliver that behavioural, help support that behavioural change. The next thematic area that we have is around resources and production, and just one example here of where there's clearly an important role for technology is in the development of a more circular economy, using blockchain or other technology to help us trace through different aspects of our resources so that we can help support the delivery of a more circular economy with less waste associated with it. The next thematic area that we have is around resilient futures, and I've already given one example here in terms of how we've been using machine learning tools to help to synthesize the information that we have around climate related risks and turn that into tools for businesses to be able to use to assess their climate related risks. The fifth thematic area we have is around transport, cities and infrastructure. And there's huge opportunities here for developing smart cities, smart zero carbon exemplar campuses of universities, for example, with ever increasing information about the energy used and other sources of emissions in those different regions. And that's just one example in which we can imagine using computer science and technology to help deliver a zero carbon world in terms of our transport cities and broader infrastructure. And then the sixth thematic area that we have is around carbon drawdown and climate repair, looking at ways in which we can either use technology or the natural world to help to draw down the amount of carbon dioxide and other greenhouse gases in our atmosphere, and thereby limit the amount of climate change. Now, the research side of Cambridge Zero is just one of the pillars of Cambridge Zero. We're also looking across all of education, from primary education through to the education of the secondary school, high school level, through to university education and continuing and executive education, and how we can help to support that. We are increasingly looking at how we can do that through digital means, and thereby have not just an direct impact on our students in Cambridge, but much more globally as well. We are very focused on external engagement and how we can ensure that the ideas and innovations that are developed within the university don't just stay within the university, but are rapidly put out into real world deployment, whether that's deployment in the policy world or deployment through engagement with business and industry in terms of solutions to climate change. And we're really keen and enthusiastic to look at ways of engaging more broadly and more deeply with a wider range of potential partners to help deliver zero carbon solutions. And then the fourth pillar of what we're doing is looking at our own carbon footprint and how we can both decarbonise and run our activities in more sustainable ways, both directly within the university, but also within the city and region, and again in collaboration with other partners to help to support what we can in terms of delivering a zero carbon future. So I hope that's given you a little bit of a sense both of what we're doing in Cambridge at the end there, but also more generally about the many different opportunities for using computer science and technology in different diverse ways to help to create a more resilient, more sustainable future. Thank you very much.
Okay, thanks Emily for that really thought-provoking talk. Now I know unfortunately you're not available for a live question and answer session now, but you and I are going to have a little bit of a further discussion around some of the points you've raised, and I hope that will address at least some of the questions that you've undoubtedly raised in our delegates' minds. So just to kick off, I wondered if you could perhaps provide some more examples of where technology offers opportunities to really move the dial on sustainability. What are those big things that we should really focus on if we're going to be ambitious about making a difference in the short to medium term?
Yeah, so I think there really are a huge range of opportunities across pretty much every sector, actually. I mean, this is one, video conferencing, clearly is a huge opportunity for further developing. We've all become reliant on it over the last few months, but it's clearly a way that really can help to facilitate emissions reductions through reducing travel. More generally, in the transport sector, again, there are opportunities as we're moving more towards electric and potentially autonomous vehicles. There are opportunities in that sector as well. In the energy sector more generally, as we roll out more smart metering and the opportunity for using energy in smarter ways, then the infrastructure in order to facilitate that is another opportunity. If you look at other sectors in agriculture, precision agriculture is starting to become ever more advanced, and the technologies to help support that, to ensure that crops are grown more efficiently. Fertilizer use is reduced as that is applied in more efficient, more precise ways. The right crops are grown at the right for the right conditions. Looking at ways of using technology to, for example, look at ways of using drones to increase the tree planting around the world. There's another potential agricultural related application of technologies. Digital twinning is starting to become ever more used in different sectors, looking at ways of optimizing the efficiency of factories, reducing energy use, reducing waste is part of that a digital twinning process, or looking at ways of making wind farms more efficient, again through using digital twinning technologies. And then the computing itself, making computing itself greener, reduced energy use is another opportunity. And then finally, another key area, which is the area that I also addressed in my talk, was the ways in which digital and computing technologies can be used to help monitor our environment. So monitor the energy use of buildings and then make that more efficient, or monitor the health of different ecosystems around the world, using remote sensing technology, satellite technology, linked together with machine learning advances, for example. So the really, everywhere you look, there are opportunities for deploying computer science, digital technologies in a way that can help reduce our impact on the world and help preserve our natural resources.
So that's great, and obviously reduced energy consumption, increased AI and ML, particularly where you're doing that nearer the sensors and embedded devices themselves rather than back up in the cloud. And implementing things like smart cities and autonomous driving. Those are all areas of real interest to ARM. But how do we ensure going forwards that the benefits of all of that aren't outdone by increased use of all these systems, and essentially we cancel out any benefits because we become ever more reliant on these systems?
Yeah, ever more reliant, or you reduce the energy use, the technologies become cheaper because you're using less energy and then you just use more of it. That is a perpetual risk in this area. And so it really is the total emissions that need to be reduced. And in terms of the climate, it's our total emissions of greenhouse gases that the climate responds to. And so it's those that we need to be bringing down to net zero. And of course, you know, it's not, as I highlighted in my talk, it's not, climate is not the only threat that we're facing. There are, you know, other wider sustainability aspects that we need to respond to as well. And actually for each of them, tackling growth and ensuring that as we grow, we do so in a sustainable way that doesn't have an ever increasing impact on our natural world is critically important. And so it's more than just per unit of whatever technology, reducing the emissions from that. It's making sure that those total emissions come down that's critically important.
And so one of the related areas that some of my colleagues are getting increasingly interested in is the use of technology in support of the circular economy. So not just in electronic products themselves, but how those technologies can be integrated into packaging, machinery, other things, in order to look at circularity across supply chains and systems. I mean, can you say a little bit more about how you think technology can help across those other sectors in implementing sustainable approaches?
Yeah, absolutely. So I think that, I mean, there's clearly huge opportunity for using blockchain or other technologies in terms of better assessing our supply chains. One of the, on the climate side of things, and again, this extends way beyond just climate, but on the climate side of things, one of the key challenges is, so in looking at emissions, people often talk about what's called scope 1, 2 and 3 emissions. And so scope 1 and 2 emissions are essentially your energy use, either direct energy use or indirect energy use. Scope 3 emissions are all the emissions that come through your supply chain. And so, I mean, for most organizations, scope 3 emissions will end up dominating, but they're really difficult to quantify. And so being able to trace those emissions through supply chains would be incredibly valuable information, and then to be able to scale that up and to be able to understand at a you know, sector by sector level or at a national level what those total emissions are in that bottom up way would be critically important. But there's lots of steps, and in order to be able to do that. So some of the steps are the technology itself. So, you know, whether that's some form of blockchain technology in order to be able to do that tracing. But then there's all sorts of other aspects that need to be thought through in order to be able to do that properly, in terms of, you know, the privacy and transparency issues on the data itself as you're passing it between different organizations, the licensing aspects and so forth. So it's quite a complex area, but one where I think there could be really huge huge opportunities. And of course it's already being used in some areas. So some aspects of sustainability, those sort of aspects are already being developed in terms of traceability of the origin of particular products, whether that's looking at sustainable fishery or sustainable wood in different sectors. So I think it is absolutely, as you say, a huge area of opportunity for development to be able to do that trace through.
And obviously you've articulated really well the role that technology has to play in all of this, but obviously there are societal and political drivers here too. Now, you mentioned in your talk a little bit about how the initiative you're involved with in Cambridge is bringing in those strands. I just wondered if you could say a little bit more about the dialogue and engagement that you're having at those levels, and how important you think that is to all of this going forwards.
Yeah, absolutely. So, I mean, clearly it's on every level, the essential thing is to get all sectors of society working closely together in a coherent and a uniform way. And that means that at both at a university level, at a local regional level, at a national level and an international level, it requires having people in academia, people in the commercial sector, people in the NGO sector, and policymakers all working coherently together. And that's required in order to ensure that we drive the appropriate level of ambition, to ensure that the policies that are put in place are policies that can properly function, that we try to, as best we can, avoid unintended consequences of those policies when they are put into real-world implementation. And we've seen many examples in the past of where in this sort of space, biofuels would have been perhaps one of the first examples where there ended up being very significant unintended consequences of first-generation biofuels from the policies that were put in place, and there have been many subsequent aspects of that subsequently. And so making sure that we had that really close connection between all the different respective parties is absolutely critical to ensure that we get the change that happens on the timescale that's required, because it is such rapid change that is needed at this stage. You know, we have somewhat left responding to climate change to the last minute, and so we don't have the opportunity to make mistakes. We really need to drive rapid, fast, significant change, and that really does mean that everyone needs to be acting together in the same direction.
So, as a computer scientist yourself, I mean, what do you see as the really key things that the industry and arm within it should be focusing on? What would you like to see us do or develop or drive in the next few years to demonstrate a real commitment to the sustainability agenda here?
So, I mean, I think, you know, in a way, as I've articulated, there's so many different opportunities, I think, for making a major difference that it's quite difficult to pick one. I think absolutely for any organisation, getting, if you like, your own house in order is the #1 critical thing. So I think, you know, really trying to ensure that the computing technologies are as green as possible has to be, you know, a sort of, no, do not pass go until you've managed to achieve that. But then I think that it, you know, actually sector by sector at where the biggest impact can be made. I mean, clearly the energy sector and trying to make us as efficient as possible our different energy systems. and the role that computer science technologies can play in that is clearly very significant. And another huge source of emissions is our transportation sector. Again, huge opportunities for deploying machine learning, AI technologies in order to improve efficiencies in that sector. I think the built environment sector, often people think about the use of computer science and technology in terms of improving building management systems, for example. That's but equally important is in the construction sector itself. I've seen examples of virtual reality systems being used, for example, in large construction projects to try and ensure, a little bit similar to doing digital twinning, actually, to try and ensure that those are optimized as much as possible. So I really, if you look through where the largest emissions are coming from at a national scale, each different sector, I think there are huge opportunities for digital technologies to make a huge impact, and it's probably going through sector by sector and picking the biggest opportunities within each of those different sectors.
Do you think standards and standards organisations have a role to play here? And they're often cited as the things that really drive change and focus minds. But in order to implement these approaches across sectors and to bring groups of companies together, I mean, is that something that we should be looking at as well?
Yeah, I think absolutely, and I think in two key areas with regard to this. So, I mean, there are many examples of where standards have often been the most effective way of driving change. If you think, for example, of the energy certifications that go on white goods that have been around for decades, or in terms of housing as well, that A to E or whatever it is, certification in terms of energy levels, hugely impactful in terms of driving change, because no one wants to have anything other than an A rating, and so you can very rapidly create change by those sort of certification systems. But essential to that is the data that lies behind those, which again comes into the sort of digital realm, and back to some of the the issues of tracing things through supply chains, for example, and whether or not technology can help us in order to be able to do that. And so coming up with standards for the data itself is also critically important. So if we were talking earlier about reporting on emissions, scope 1, 2 and 3 emissions, but again having common standards of the data that is being reported is also critically important. So and creating frameworks and abilities to easily access different types of data in common formats across this whole space is another area where there's a huge opportunities.
And there's certainly plenty to consider there for us, both internally then and in the discussions that we have with people outside of the company and with our university collaborators. Just to finish, I'm aware that the UK is hosting the next big international climate conference next year, COP26. And I just wondered what you think what you would really like to see coming out of that in terms of everyone internationally demonstrating a commitment to sustainability going forwards. What are the key headlines that you would like to see?
Yeah, so as you say, it was supposed to be this November, but it's been delayed by a year because of the coronavirus situation. So next November, the UK is going to be hosting the next big climate conference. So this is every 5 years. Well, now it will be 6 years. There's a particularly large climate meeting, the last one being in Paris in 2015. And so at this one, the intention is to bring together the international community and to review national commitments around climate change, and to look to see where we need to be raising ambition. So I guess there are a number of things that we would really be hoping to come out of that meeting. First of all, to see nation by nation a raising of ambitions in line with what the climate science says is necessary to limit climate change, as was agreed in Paris, to ideally 1.5 degrees, no more than 1.5 degrees of warming. But a critical part of that is to build up internationally commitments to ambitious dates for reaching net zero emissions. So in the UK, we have now a target of reaching net zero emissions by 2050. If that sort of level of ambition can be replicated country by country, and not just country by country, but also organisation by organisation, so setting organisation by organisation ambitious dates for net zero emissions is also a critical part of that. So the path to a rapid global transition to net zero is an essential part of reaching of limiting climate change. But the other aspect of this is that there's not only an international climate conference, but there's also an international biodiversity conference happening at much the same time. And so similarly, looking at our other impacts on the natural world and ensuring that as countries, but also as organisations, we're also limiting that impact is also a critical part of that international policy landscape.
Great. Well, thank you very much for your time. That's been a really interesting discussion, and I'm sure that those watching live will have found it just as interesting and stimulating as I have. Emily Shuckburgh, thank you very much.
Thank you.